When a body is fully or partially immersed into liquid at static condition, then you see that liquid can apply upward thrust on the body. This upward thrust is called buoyancy. Suppose, my dear student, when a boat is kept into the water, then you see that this boat floats. And why this boat floats? Because the water can apply upward thrust on the boat. And because of this upward thrust, boat can float on water. Okay. So when you kept or when you keep a body inside water, you see that the upper part of the water can apply the downward force, and the downward part of the water can apply the upward force, and this upward force is called buoyancy. So at first I'm going to write down the definition of buoyancy. So let's see what is called buoyancy. My dear student, when a body is fully or partially immersed into liquid, then this body will feel an upward thrust. An upward thrust. Then this body will feel an upward thrust. This upward thrust is called buoyancy. My dear student, to show this, at first I'm taking a container of water. Suppose, my dear student, this is a container, and this container having full of water, and this is the upper surface of the water or liquid. Suppose a cylindrical shaped body inside the liquid, and this is the cylindrical shaped body, and this body is inside the liquid. Suppose this is A, B, C, and then D. At first, let's take the height from the upper surface of the liquid to the upper surface of the cylinder. This height will be equal to H1. And then the height of the cylindrical shaped body is H, my dear student. And then the height of the cylindrical shaped body is H. So here H is the height of the cylindrical shaped body. And then you see that the height from the bottom surface to the upper surface of the liquid is H2. And this liquid having density, and that density is rho. Okay, rho is the density of the liquid. Okay, my dear student. So in this particular case here, rho is the density of this liquid. At first you see that the liquid that stay upward side of AB can apply the downward thrust. Since it can apply the downward thrust, okay. So because of this downward thrust, or because of its downward thrust, okay, it can apply a downward force. And this downward force will be equal to, suppose, F1. So here, F1 will be equal to what? The liquid which stay at the upper surface of the cylinder, and then this liquid can apply downward thrust on the cylindrical shaped body. And this F1 is nothing but the downward force. Now, my dear student, the liquid that stay at the bottom surface of the CD can apply an upward force. And this upward force will be equal to F2. Because of acting here F1 and F2, the net resultant thrust that is applied on this body, my dear student, the net resultant thrust that is applied on this body is called buoyancy. So buoyancy is nothing but what? Buoyancy is nothing but here the net upward thrust, the resultant upward thrust that is applied on this body because of pressure, due to pressure. Okay, and this function is called here buoyancy. Now we can say that, my dear student, now we can say that at first I'm going to calculate F1. You know that the pressure P1 that is applied by the upper surface of the liquid to the upper surface of this container, and this pressure P1 will equal to what? This pressure P1 will equal to here F1 divided by A. And what is A? A is the area of cross section of this cylindrical shaped body, my dear student. What is called cross section part area? You see that? You see a marker, okay? And the black part of this marker indicate that the area of cross section of this cylindrical shaped body, my dear student. The black part of this marker can indicate the area of cross section of this cylindrical shaped body. Okay. Now, I'm going to find out the value of F1 from here. So F1 will equal to what? Will equal to P1 into A. And then, my dear student, here you can say that here F1 is nothing but P1 into A. So what is the value of P1, my dear student? P1 is nothing but H1 rho into G multiplied by A. And it will equal to AH1 rho into G. So this is, my dear student, equation number 1. I repeat, my dear student, this is equation number 1. And then you see that, my dear student, the liquid that stay at the bottom surface of CD, and this liquid can apply an upward thrust. And when this liquid can apply an upward thrust, okay, that particular upward thrust is nothing but buoyancy. My dear student, that particular upward thrust is nothing but buoyancy. Since buoyancy is nothing but that particular upward thrust, that's why you can say that here F2 similarly it will be equal to A H2 rho into G, and this is equation number 2. F2 is acting vertical upward direction, and you see that F1 is acting vertical downward direction. So because of acting F1 and F2, my dear student, because of acting F1 and F2, okay, the resultant thrust that is applied on this body, and that resultant thrust must be acting at the upward direction because F2 is greater than F1. Okay, and this resultant thrust is nothing but buoyancy. So you can say that buoyancy force will equal to what? Resultant thrust in between F2 and F1. So this is the resultant thrust in between F2 and F1. That's why put down the value of F2 here. F2 equal to AH2 rho into G minus F1 equal to what? AH1 rho into G, my dear student. Now take a common here, A, and then this is H2 minus H1 rho into G. Will equal to what? This will equal to here A, H rho into G. My dear student, this will equal to what? This will equal to here AH rho into G. So this AH rho into G is nothing but the buoyancy force. You know that, my dear student, here A is the area of cross section, H is the height. So area of cross section into height is nothing but the volume, my dear student, volume then rho into G. Okay, so this is the formula for the case of buoyancy. But remember one thing, my dear student, remember one thing, and that is for the case of buoyancy, here rho is the density of liquid. Density of liquid, my dear student, here rho is nothing but the density of liquid. And then, my dear student, what is V? Here V is nothing but volume of displaced liquid. Displaced liquid. So let's understand this volume of displaced liquid properly. My dear student, let's understand this volume of displaced liquid properly. Suppose this is a very small rectangular body, my dear student. This is a very small rectangular body. If this very small rectangular body, if you want to keep it inside water, my dear student, if you want to keep it inside water, then you see that suppose it's this is the water level. Suppose this is the water level. Okay. And then you see that some part of the body is inside the water and some part of the body is above the water. My dear student, you see that some part of the body is inside the water and you also see that some part of the body is above the water. Since here some part of the body is inside the water and here some part of the body is above the water. That's why, my dear student, this is the volume that indicate the volume of the displaced liquid. My dear student, this is the volume that indicate the volume of the displaced liquid. Okay, so this part indicate that volume of the displaced liquid. My dear student, this is the volume of the displaced liquid. Okay, so what is called volume of the displaced liquid? If you keep a body into the water, into the liquid, you see that the part of the body that stay inside the water. I repeat, my dear student, the part of the body that stay inside the water, or the part of the body that stay inside the liquid, that is called volume of the displaced liquid. My dear student, that's called what? That's called here volume of the displaced liquid. Okay, suppose you just want to cross a river by using boat. When you stay on the river, on the boat, then you see that some part of the boat is inside the water, and the part of the boat that is inside the water indicate that volume of the displaced water or volume of the displaced liquid, my dear student. So about this discussion, my dear student, anyone have any confusion? My dear student, anyone have any confusion here? My dear student?
Sir,
No, sir.
Yes? Yes,
sir,
I'm
it's a
hearing.
volume of
Sir.
displaced liquid.
Yes, I'm hearing. My dear student?
Sir, volume of displaced liquid ঠিক করে বুঝাবেন?
Okay, very good, no problem. You see that this is a rectangular shaped body, my dear student. You see that here A, B, C, D is a rectangular shaped body. Okay, if you consider the total volume, my dear student, will equal to what? Total volume will equal to the volume of ABCD. But my dear student, if you keep this body into the water, I repeat, my dear student, if you keep this body into the water, then you see that some part of the body inside the water. I repeat, my dear student, you see that some part of this body is inside the water. And the part of the body that is stay inside the water, the part of the body that stay inside the water is called volume of the displaced liquid. Suppose you see that this is the level of water, my dear student. This is the level of water. Okay, if this is the level of water, then the part of the body is inside the level of the water. I repeat, my dear student, the part of the body that stay inside the level of the water is called volume of displaced liquid. It's called what? It's called here volume of displaced liquid. So the part of the body that stay inside the water. My dear student, is it clear?
Yes, sir, clear.
Any more question, my dear student? Any more question here? Any one of you?
স্যার
Yes?
স্যার F2 এর ইকুয়েশনটা একটু আরেকবার বুঝাবেন?
Okay, very good. You see that here F2 comes from what? Here F2 comes from the pressure P2. You see that the bottom surface can apply the upward pressure P2. Okay, can apply the upward pressure P2. Okay, so since it can apply the upward pressure P2, so let's see how can I find out the upward pressure P2. Okay, let's see this, my dear student. You see here, upward pressure P2 will equal to what? Upward pressure P2 will equal to here, this nothing but F2 divided by A. My dear student, this nothing but what? F2 divided by A. F2 equal to here, F2 equal to, you can say that A into P2. P2 is the pressure at H2 depth, my dear student. P2 is the pressure at H2 depth. So a liquid having depth H2 can apply pressure. It will equal to what? It will equal to here H rho G. And rho's, this is the formula for the case of upward force F2. F2 will equal to what? AH2 rho into G. Is it clear to you, my dear student?
Yes, sir.
Okay, very
Thank
good.
you, sir.
Very good. Now, my dear student, I want to know detail about weight. So let's see how can you find out the weight of a body. So detail about weight, my dear student. So weight. You see that, my dear student, what is called weight? Weight is nothing but the upward thrust, the downward thrust that is applied by body along the center of the earth. Okay, because of gravity is called weight. So weight is nothing but W equal to M into G. Weight is nothing but here W equal to what? W equal to here M into G. So since W equal to here M into G, my dear student, since W equal to here M into G, okay, I'm going to describe this M on the basis of the density rho. You know that density rho will equal to what? Will equal to mass per unit volume, my dear student. Mass per unit volume. So here, what is mass M? Mass M equal to rho into V, my dear student. Mass M equal to what? Mass M equal to here rho into V. So M is shifted by rho into V into G, or you can say that this is V rho G. So what is rho here? Rho is the density of body. My dear student, rho is the density of body. And what is V? V is the total volume. My dear student, V is the total volume of body. My dear student, V is the total volume of body. Okay, so there's a little bit difference in between weight and upward thrust or buoyancy. My dear student, there's a little bit difference in between weight and upward thrust or buoyancy. Okay, so this is the little bit difference in between the weight and upward thrust or buoyancy. Any confusion, my dear student? Up to this
No, sir.
discussion, any confusion here, my dear student? Any one of you? Any one of you, my dear student? Any confusion here? Okay. So if you have no confusion, then I'm going to solve next topic, my dear student. The next step I'm going to discuss about the flotation. Flotation and immersion of a body. My dear student, next step I'm going to discuss about the flotation and immersion of a body. Okay. I repeat, my dear student, in next step I'm going to discuss about the flotation and immersion of a body. Okay. So flotation and immersion of a body. So let's see. My dear student, you see that if this is a body, then weight is acting vertically downward direction is weight. Buoyancy is acting vertically upward direction, that is called F up, upward force. It's called buoyancy. Okay. So it's W. W is called weight. So what is F up, my dear student? This is called weight. So this is called upward thrust or buoyancy. Okay. Now, if weight is more than upward thrust, then what will happen? This body will sink definitely or immerse definitely. My dear student, this body will sink or immerse definitely. In which condition you can say here, my dear student? In which condition you can say this? When weight is greater than upward thrust, then definitely we can say that this body will sink. I repeat, my dear student, definitely we can say that this body will sink. Okay. And then, my dear student, when you see that upward thrust is more than weight, then what can we say? If upward thrust is more than weight, then we can say that this body will float. Okay. Then this body will float. So, my dear student, so in which case this body will float? So you can say that when upward thrust is greater than weight, then this body will float, and when weight is more than that of upward thrust, then this body will sink. Now, my dear student, when these two parts are equal, suppose upward thrust, my dear student, upward thrust will equal to weight. Then what would be the conclusion? My dear student, when upward thrust will equal to weight, then what would be the conclusion? This body will sink fully inside the liquid. I repeat, my dear student, this body will sink fully inside the liquid, but in a floating condition. But in which condition? In a floating condition. Baba. আমার কাছে যাও, বাবাকে পড়াচ্ছে না এখন, আমার কাছে। So my dear student, in this case you can say that this body will float fully, sink inside water. Okay, so these are the conditions, my dear student. I repeat, my dear student. So these are the condition. Okay, so this body will float or emerge. So I'm going to solve a mathematical problem on the basis of this topic. So let's see a mathematical problem on the basis of the condition of flotation or immersion of a body. Now, my dear student, suppose this is a body. Suppose this is a body. Okay, so this body having length is suppose 2 meter, breadth is 1.5 meter, and height is 1 meter, my dear student, and height is 1 meter. Okay, and height is 1 meter. I'm going to put this body inside liquid, and this body having density rho will equal to what? Rho will equal to 850 kg per meter cube. Okay, and the name of the body is here, body A. Now my question is here, if this body A is kept into water, is kept into water, then do you think it will float or sink? Okay, then do you think it will float or sink, my dear student? So this is the question. So do you think it will float or sink? So my dear student, this is the question. Okay, so you see that a rectangular shaped body having length, breadth, and height is given, and also, my dear student, its density is given. And if I'm going to keep this body into water, then let's see, will it sink or float? My dear student, you know that the flotation and immersion depends on which quantity? My dear student, the flotation and immersion depends on which quantity? It depends on number 1, buoyancy, and number 2 is what? Is weight. So before find out this, at first I'm going to find out the total volume of this body. So total volume of this body. Total volume of this body. V will equal to what? Will equal to length into breadth into height, my dear student. So length is 2 meter, breadth is 1.5 meter, and then height is 1 meter. It will equal to what? 3 meters square. So this is the volume. my dear student. So this is the volume. So here, volume V equal to what? Volume V equal to here, the product of length, breadth, height. It will equal to 3 meters square. And then, my dear student, in next step, I'm going to find out which quantity. It's buoyancy or upward thrust. So, buoyancy or upward thrust. F upward will equal to what? V rho G. Remember, if you want to calculate buoyancy, then there are two equations for the case of buoyancy. First step, if you put down that body into the water, the calculation is here, V rho G, and this we define that, indicate that the volume of the displaced liquid. But before keep this body into the water, if you want to find out the buoyancy, then this will indicate that the total volume of the body. You see that in this particular case, body A, just before keeping this into the water, we're just going to know that this body will float or sink. See, since we're going to know that this body will float or sink, that's why we can say that this V indicate that the total volume of the body for the case of both weight and upward thrust. My dear student, this point is clear to you or not? My dear student, this point is clear to you.
Sir, the unit of volume will be meter cube, not meter
Meter,
square.
meter cube, exactly. Good, very good. Very good. Okay. But this point is clear to you, my dear student.
Yes, sir.
Okay. So here V equal to 3 meter cube. And what is rho? In this particular case, rho is the density or concentration of the body. My dear student, what is rho? Rho is the density or concentration of the body. So density or concentration of the body is nothing but 850. And what is G? G equal to 9.8. So if upward thrust will equal to something Newton, my dear student. If upward thrust will equal to what? It will equal to here something Newton. Now, what's the value of upward thrust? F upward.
24990 Newton.
24990 Newton. Okay, good. Now, in next step, my dear student, I'm going to find out the weight of this body. In next step, I'm going to find out the weight of this body. So, weight of this body, W, will equal to what? Will equal to here V rho G also. But in this case, what is rho? In this case, rho is the density. Okay, I got a mistake here. This is 1000 because this is upward thrust, my dear student. So since this is upward thrust and upward thrust is applied by the liquid, upward thrust is applied by the liquid, by the student. Since upward thrust is applied by the liquid, so here rho is the density of the liquid. And when you calculate the weight, then here rho is nothing but rho B. And this is the density of the body. Okay. Find out the upward thrust if upward here.
Sir, 29400.
29400. Okay. And then volume V equal to 3. And density of the body is here 850.
স্যার এখানে রো এর ভ্যালু 1000 কেন আসলো?
Okay, when you calculate density, when you calculate upward thrust, you see that upward thrust is applied by the liquid. That's why for the case of buoyancy, or to calculate buoyancy, rho equal to 1000 is the density of the liquid. Okay, rho is the density of the liquid.
ওকে স্যার।
So my dear student, so what is the weight of this body? So what is the weight of this body, my dear student?
24990.
24990 Newton. Okay. Now, my question is here. This body will float or sink? My dear student, my question is here, this body will float or sink? Is it correct? I think this is not correct answer. I think answer is not correct here. Please check